If you're a SAS programmer, you're likely wondering whether your code must change in SAS Viya. Before we dive in and address that question, let's first discuss a few key concepts. The SAS Viya platform includes multiple servers to execute SAS code. The two primary servers are the SAS Compute Server and SAS Cloud Analytics Services, or CAS. You can think of the SAS Compute Server as equivalent to the SAS 9 Workspace Server. Your familiar SAS 9 programs can be submitted as is, and by default, they'll run on the Compute Server. There's no need to learn new syntax to use the Compute Server. SAS Cloud Analytics Services is a high-performance server that performs parallel processing on in-memory data. It's likely that you'll use CAS for your big data and complex analytics. Often, only very minor code modifications are required for programs to run in CAS. There are different ways to submit requests to CAS. You can use the familiar syntax of CAS-enabled data and proc steps, or you can learn the native CAS language, CASL. CASL is a scripting language that's used to call CAS actions. Each CAS action performs a single task and includes parameters to customize the action. CASL can be executed in SAS programs, as well as integrated with open-source languages, including Python and R. For programs to process in CAS, data must be loaded into memory. In-memory tables and the associated physical data sources are organized and referenced via CAS libs. Depending on your permissions, you can create your own CAS libs or leverage CAS libs defined by your administrator. Each of us have access to a personal CAS lib named CAS User, in which we can load in-memory tables for our own use. An in-memory table can have either session or global scope. Session scope means that the table remains in memory for the duration of the CAS session, whereas global scope tables persist in memory after the session ends. If you want to use in-memory data in other applications, such as SAS Visual Analytics or Model Studio, then tables must be promoted to global scope. The application that you'll use to develop code is SAS Studio. To open SAS Studio, click the Applications menu and select Develop Code and Flows. I encourage you to follow along with me to try out these steps for yourself. Your environment may already have the files used in this demo. However, if you don't see them, please visit our SAS Software GitHub page. The SAS Viya Quick Start repository provides the files used in our demonstrations and instructions to load them into your environment. Navigate to Files, Home, Quick Start, and then open the Compute CAS-CASL.SAS program. The first three statements read the sample data used in this demonstration from the SAS support website and create the Home Equity SAS table. I'll highlight these statements and click Run. The generated report shows CAS file information for the Home Equity table. The first section of the program includes code that was originally written for SAS 9. Notice that the program includes a libname statement pointing to a Windows folder and a data step that creates a permanent copy of the Home Equity table, creates new columns, and assigns labels and formats. The proc contents step lists the table and column attributes, procfreq generates frequency counts, and procmeans creates an output table with summary statistics. What needs to change to allow this program to run in SAS Viya? I simply need to update the path in my libname statement to reflect the location of the data in my new environment. I'll highlight the path in quotation marks, and then use the Explorer to right-click the Quick Start folder and select Insert as Path. That's it. I'll highlight these steps and click Run. This program executes on the SAS Compute Server. It processes the data just like the SAS 9 Workspace Server and returns results for proc contents and procfreq, and output tables for the data step and procmeans. What if you want to take advantage of the CAS server to process in-memory data? I can make minor modifications to my program to make that happen. First, I need to start a CAS session. A simple CAS statement with the name for the session, my session, will do. Second, I need to load my data into memory via a CASLib. I'll show you two methods. One option is to use the CAS-UTIL procedure. The load statement loads a variety of file types, including SAS tables, CSV files, Excel files, and DBMS tables. This load statement reads the work.homeequity SAS table and creates an in-memory table named homeequity in the CASUser CASLib. This is a simple and efficient way to import and load data. I'll highlight and run the CAS statement and proc CAS-UTIL step, and the log confirms that homeequity was successfully loaded. Here's a pro tip. There's a great snippet available that includes a variety of options using proc CAS-UTIL. In the snippets pane, if you expand SAS via Cloud Analytics Services and open Load Data to CASLib, you'll see 3 scenarios for loading data and template code for each one. Back to my program. Another method to load data into memory is the data step. If you designate an in-memory table in the data statement as your output table, the step will execute on the compute server, but the final result will be loaded into memory. Note that the way we reference tables in data and proc steps is with libref.tablename. A CASLib is not the same as a libref, so I must define a library reference to connect to my CASLib. An easy way to do this is to submit the following statement: CASLib_all_assign. After I run that statement, each CASLib is mapped to a corresponding library reference with the same name. In the Libraries pane, I see cloud icons for each of the librefs mapped to CASLibs, including CASUser. If you have many CASLibs in your environment, an alternative is to assign a libref to a single CASLib. This libname statement would only assign the CASUser libref to the CASUser CASLib. Let's examine what's different in this program. In the data step, I've simply changed the output table in the data statement to an in-memory table by referencing CASUser. That's it. I'll highlight the data step and click Run. Remember, this step processes on the compute server, but the result is an in-memory table available in CAS. If the input table on the set statement and the output table are both in-memory data sources, then the entire step can process in CAS. I'll change the input table to CASUser.homeequity, then rerun this data step. The log indicates the step ran in Cloud Analytics Services. For complex data steps and large tables, this can result in significantly faster execution. What about the procedures? Some base SAS procedures are fully or partially CAS-enabled if you reference in-memory tables. SAS documentation will be your best guide. This page lists procedures that can run in CAS. Notice that proc contents and proc means are included, but procfreak is not. But don't worry. Many of our base SAS procedures have a corresponding optimized CAS procedure. Instead of procfreak, we can use procfreaktab. And although proc means is partially CAS-enabled, we'll likely see the best performance using the similar procmd summary step that is designed exclusively for CAS. In my program, all input and output tables in the procedures are in-memory tables. Procfreak is now freaktab, and means has been changed to MD summary. The rest of the syntax is the same. Let's run these steps. The results look the same compared to the previous program. However, the log indicates that procfreaktab and procmd summary executed in CAS. Behind the scenes, these steps are converted to CAS actions and then executed in CAS. Although the data we're working with is not large enough for you to notice a significant difference in execution time, I promise that with large data and complex analytics, you'll be amazed with the processing speed of CAS. If I look in the Libraries pane, I can see that in the CASUser CASLib, I have homeequity and homeequity summary, both saved as in-memory tables. But what happens to these session scope tables when the CAS session ends? I'll submit the CAS terminate statement, which drops session scope tables from in-memory and deassigns all librefs mapped to CASLibs. If I want to ensure that home equity persists in memory in CASUser, I need to promote it to global scope. In ProcCASUtil, I can add the promote option in the load statement. Or in the data statement, I can add the promote equal yes dataset option. Note that if you want to reload a global table into memory, you must drop it first. Finally, let's look at the last version of our program that uses CASL. In a SAS program, CASL is submitted inside a ProcCAS step. First, I'll create a dictionary named TBL that I can reuse each time that I want to reference the home equity table in CASUser. Next, I'll store my data step code as DS and place it inside the source and end source statements. The subsequent statements each call a different CAS action. Table.dropTable deletes the in-memory table if it exists. Upload loads the table. Datastep.runCode executes the DS source code. Table.columnInfo produces a report with column information, similar to proc contents. Simple.freq calculates frequency counts. And simple.summary creates an output summary table. This collection of CAS actions produces similar results as the previous programs with lightning speed. That will get you started programming in SAS Viya, but obviously there is much more to learn. I encourage you to visit the SAS Learning Center for many great free training options and other helpful resources.